have you ever been interested to know why the derivative of e to the x is just e to the x? Well, it turns out that if you set your f of x equal to e to the x, then if you go through the entire process of trying to expand e to the x out, then the process is actually very much the same as trying to come up with the approximation for what e is. I can do an entirely separate video about how to come up with the approximation for each term for e to the x, but I guess if we are going to take f of x equals e to the x, then what we would find out from doing that is that it can be expressed in terms of 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial, continuing on. And okay, so given this as a way to expand e to the x, then this should look an awful lot like a case of the sum rule, which is, as we saw it in the other video, the sum rule implies that dx of some f of x plus g of x equals ddx of f of x plus ddx of g of x. In other words, you're able to break them in pieces. I did a video about this, so if you haven't seen it, go look for that. And also, each of these pieces, you'll be pleased to notice, is just a polynomial in itself with just one term. So because of that, we can just refer back to my video where I derived the power rule, where we found out that if we have if y equals something in the form of k minus x to the n plus a constant, then y prime, or the derivative of this, can be represented in the form of n k x to the n minus 1. So we're going to need to use both of these here to figure out how to do this. So let's call each of these individual pieces something else here. So actually, let's go ahead and let's call this just y, and let's say that we're gonna be able to write this in a new way as y equals f of x plus g of x plus h of x plus I of x plus j of x plus some k of x, continuing on, where each of these pieces are each of the terms being added here. So let's go ahead and take the derivative of each of these pieces and see what we come up with. So we're going to get that y prime is going to equal f prime of x plus g prime of x plus h prime of x plus I prime of x plus j prime of x plus k prime of x, continuing on. So we need to figure out what all these pieces are going to equal. So we're using our f of x in this case to be 1, g of x is x, and our next piece is h of x equals x squared over 2 factorial, I of x equals x cubed over 3 factorial, j of x equals x to the 4th over 4 factorial, and k of x equals x to the 5th over 5 factorial. So this would imply we're just going to use the power rule for each of these pieces here. So notice how here 1 is the constant or the coefficient, and so basically this is going to be in the form of well, just imagine 1 as being 1 times x to the 0, because that's what this is technically. So because of that, our n value is going to be 0, so this implies that f prime of x equals 0 times 1 for our k, constant there, times x raised to the power of 0 minus 1, but it's 0 times all that, so that's just going to go to 0. And how about this one? So g prime of x is going to equal, well, that's just like saying x to the 1st basically, so we're going to have 1 times coefficient of 1 times x to the 1 minus 1, that's x to the 0, power just 1, so that piece is going to be 1, and what else? So h prime of x equals, well, in this case 1 over 2 factorial is going to be the coefficient, so we're going to have 2 for n times 1 over 2 factorial is just the same as 2 times 1. If you know what your factorials are, so notice we have a 2 on top and a 2 in the denominator, so those are going to cancel out, and we have our x to the power of 2 minus 1, so that's just going to be like x to the 1st, or just x, and I of x, so we're looking for I prime of x, so that's going to equal 3 for our n, times the coefficient 3 times 2 times 1 for 3 factorial, times x to the 3 minus 1, or cancel the 3's, we're just left with x squared over 2 factorial. Now onto the j piece, j prime of x equals 4 for our value of n, the coefficient is 1 over 4 factorial, so 1 over 4 times 3 times 2 times 1, and multiply that by x to the 4 minus 1 equals x cubed over 3 factorial, and k of x being x to the 5th over 5 factorial implies that k prime of x is just going to equal our n value is 5, our coefficient is 5 factorial, or 5 times 4 times 3 times 2 times 1, so 5's go away, and times x to the 5 minus 1 equals x to the 4th divided by 4 factorial, and hopefully you can see what's going on here. So now if we plug all this back in, we're going to get that y prime is going to equal 0 plus 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, continuing on. And note that the 0 doesn't do anything, so actually y prime is just going to be represented by 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. And notice here that we're going to get the exact same thing. So in this case, y equals y prime, or we could even go so far as to say, or even y equals dn of f dxn equals e to the x. In other words, this notation here basically is saying regardless of how many times you take the nth derivative of our f of x with respect to our x, we're just going to get out the same result. Ultimately, that we're going to get y equals e to the x again. So yeah, this is how you come up with this result, and hopefully you found this helpful, and come back for the next one where Joe shows you how.